Miscoll with EMS Now, and welcome to this edition of the Eric Miscoll Show. It's 7 a.m. in Dallas, it's 2 p.m. in Munich, 3 p.m. in Tel Aviv, and 11 p.m. in Melbourne. So we are spanning the globe here with this one today. Our topic today is we're going to address the question of, can AI make EMS smarter? And to help us with that, because Phil and I aren't that smart, we've invited two people who know a lot more about it than we do. We have joining us today Sebastian Schaal, the founder of Luminovo, and Zeev Efrat, he's the CEO of Cybord. As always, we have Phil Stoten, my co-host, joining us, and he's the late one for 11 p.m. in Australia over there. Our guests got the good time slots today, I think. So
that's the way it should be.
As it should be. So let me begin by first letting the guests kind of introduce themselves, then we can get into some questions here. Zeev, why don't we begin with you, sir?
So thank you very much for inviting me to this session. I'm the CEO of Cybord. Full name is Zeev Efrat. About 30 years in the business of startups and initiating new companies and technologies. This is the last one. This is the nicest one, and this is going to be the one that actually going to make an impact in the electronic business where I'm dealing with for 30 years.
Okay,
Very good.
Sebastian, tell us about yourself and Luminovo.
Yeah, so I'm Sebastian, one of the founders and MDs of Luminovo. I'm originally an electrical engineer, started out here in Munich, and then went a little bit into the computer science route. Did my master's in the Valley at Stanford, and after that was very much sucked into the force field of artificial intelligence. And Luminovo is basically, there's been two phases of Luminovo. The first phase was really us acting as an AI agency, really helping businesses in the manufacturing field, but also on the business process level to really understand what AI can do for them and then apply it into their business. Before we felt this was like too much project work, and we wanted to bring this knowledge into the industry where my co-founder and I are originally from, being electrical engineers, and combine both worlds. And currently Luminovo is a software provider for the electronics industry, which are a large focus on EMS. And we are mainly helping EMS navigate their most important business processes, which is when you're a bespoke manufacturer, this is mainly quoting and procurement, and then of course having all the inputs that are needed to make that effectively. That's where we are.
Okay.
Very good.
Hey, Sebastian, just a quick question with respect to that background. When you started basically as a consulting company, were the EMS projects the best projects that you had? Was it like that's where you recognized you could have the most impact and add the most value?
It's funnily, I would say at the time when we started, I would say the ordinary EMS company didn't have like the R&D play money budgets to really invest in this boutique service that we were at the time. So we didn't really work with like the kind of customers and the like mid-level EMS companies that we saw that of today, but we worked with Infineon. So it was not on the board level, but on the chip level. And this was our most impactful project, that we helped Infineon accelerate the development time of their Oryx chip, which was mainly about reducing their constrained random verification approaches for their chips before they actually go into tape out. And this is where we saw like tremendous potential of like saving redundancy in their simulations. And the statement of the research director at the time was, Sebastian, we probably saved you tens of millions of dollars, but that's not the fun part. The fun part is being 3 months earlier to market. And I think that was really for us this inception where we said, if we can use AI in a sense of technology to accelerate the time to market for the most vital innovations, then that's really where we can add the most value to society. That's basically how the journey went.
Yeah, no, it's fascinating, isn't it? It's interesting that your big customer in the manufacturing space was actually an OEM, and I think that kind of reflects a little bit Zeev's experience. Your product is focused around providing traceability and component information mainly to EMS companies, mainly to OEM companies within EMS companies. Is that correct?
That's correct. Practically, we are the whole concept started from a situation our founder had, that a big project was almost canceled because of a tiny capacitor, which is tiny but effective on the board, and the board stopped working and come back from the field. Now, we understood at that point of time that nobody's actually checking any component. So components are not checked before they're placed on the PCB. And if they're not checked, so there are defects, there's counterfeit, there's other corrosion situations that they found it either on the test phase or on the field. And we came with the concept that every component should be checked. Every component, which means all those tiny capacitors and those expensive chips, they're all going to be checked. And we are actually using the machines themselves. There's no hardware there. The machines themselves take the images of those components as part of the process. So there's no hardware additional thing in it. And we are taking those images and we are able, using deep AI, to really identify every component where its source is. So if I know your mother, it's probably a good one. And if I don't know your mother, then probably you're coming from somewhere that I'm not sure I want to buy.
Yeah.
And that's the situation, and that's what we're doing it. And the key process is actually building a huge database. We're talking about 2.5 billion now, growing about 200 million a month, and that's the kind of database that we are talking about. And maybe later on we'll give Sebastian some access to it so he can build the bill of materials more accurate. But we'll talk about it later.
Hey, Zeev, let me dive in on something you mentioned. We talked about this before too. You just used the term kind of the deep. There's AI, there's material. So let's define some terms here. So you said kind of the deep. So talk about those different levels. We talk about kind of machine learning in the industry is kind of thrown around, which I think is just kind of an application of AI, but kind of talk about the distinctions there, if you would.
I mean, we're talking about very deep neural networks, and we're giving, for example, we see a capacitor coming from Samsung, and we have in our database, let's say 10 million capacitors like that. So we know how all those capacitors from Samsung are coming, and if they are cut in different locations, we will know how to distinguish between them. And that's actually the difference. If we get only 5 or 6 or 100 examples of something, then the accuracy will be lower. Now, the beauty about it is to build networks that are able to manage those amounts of quantities and still have models that will work under 100 milliseconds. So our goal is to say yes, no, or problem with a component within less than 100 milliseconds. And why is that so? Because in the future, we will be able to tell the SMT, the pick and place machine, drop the item. We are not able to do that now because there's difficulties with the APIs with the pick and place machine yet. But the whole goal is that practically we will tell the pick and place machine, drop those items and continue, or drop this reel and don't continue at all. And this needs to be very fast because we don't change the throughput of those SMT lines.
And all the terms that we hear around AI and machine learning, are they, when people talk about AI, are they all talking about the same thing, or is there a little bit of confusion there? You mentioned an analogy earlier, which was this ideal of you tell a child that a cat in front of it is a cat, and for the rest of its life, it knows what cats look like. But AI isn't that smart. It has to look at a lot of cats before it can figure that out. So just explain that kind of hierarchy of.
I mean, a capacitor is a capacitor, but now the name of the game here is that if we would try to identify each of those capacitors, and we are talking about millions or more than millions, we won't be able to do it in time. What we are looking at is the packaging. Now, the places that are packaged is very limited. So it's let's say 1,000 places in the world are doing packaging. So we don't need to know so much information, but we do need to know how this packaging is done. And we need to have a lot of examples. And that's the reason why we're building those huge databases of images. It is really reflected in the accuracy of the system. So we are able to go to accuracies of 98.5 or even more, even higher. And as well, later on, do what we call surgical traceability. So if you give me an image of a faulty component, I will be able to go down to the 5 or 10 capacitors or chips that are probably most similar to this chip. So you don't need to do a recall for all the lot, just do a recall on those 10 boards.
Okay. Yeah.
If you want, happy to like jump in, and because I had to basically come up with lots of like frameworks to explain this at the time when we were still working at this consulting service. Maybe I'm happy if you can also see it differently. So I always frame it as that basically AI is in a sense the most general concept you have. Like in theory, if a computer system is able to perform a task that requires some form of human decision making, human intelligence, you can already call this an AI system. So basically, it doesn't answer the question how it's doing it, but just what problem it's solving. Think of like complete different application, medical field. You have a list of all your kind of the blood values that from the test results that came in. You feed this into a system, and the outcomes tells you which disease you have. This is normally something that we would have no idea how to read that chart. So the system is clearly doing something a human expert is needed. But only if we open the box and we answer the question how it's doing it, we have a differentiation between a classic AI system, an expert system, which has been around since the early 50s, and this new paradigm of machine learning, which an expert system is really like a doctor sitting down, codifying every single interaction. If this value is high, this is low, then XYZ. So basically a huge decision tree.
Yeah.
Then this could be as smart or even smarter than like another system, but it's like a classic AI system. Machine learning, on the other hand, doesn't have explicit rules that are embedded by a human, but it tries to find these interaction terms by mathematical optimization. So it has a lot of examples, and that is comparing what's the most common denominator of, for example, a diabetes patient, and then tries to find that mapping. And that's then this inner term. And in machine learning itself, you can then dive a little bit deeper and then ask yourself the question. So we have this kind of self-learning mathematical optimization, but what mathematical model am I actually using? Am I using something that people know from their statistics class, like linear regression, for example? That's like a classic machine learning, classic statistical approach. Or am I using this new paradigm of computing, which is deep neural networks, which is like a very flexible architecture that can be has been our gate towards like more interesting pieces of data, the vision data that Zeev's talking about, the text data. And then if you choose a machine learning system and you choose an algorithm that's based on deep neural networks, then you are at this term of deep learning. So you have like these three circles that all self-containing each other. And overlaying this is the industry standard effect that people call the AI effect, where people say everything we can't do today is AI, and everything else is basically just computer systems. It's like a real thing. Yeah. You can look it up at Wikipedia. And that's why there's so much confusion about this terminology. And people say, oh, we're doing machine learning, but not AI yet, which is clearly, by its definition, just wrong.
That was excellent. Thank you. Hey, Sebastian.
I understand a lot, but I still have a lot more questions. But go on.
But Sebastian, were you going to add something, Zeev? I'm sorry.
No. Take Sebastian. I will.
Okay. No, Sebastian, I was going to ask you. So take off that. Zeev was explaining kind of how his application, what they're doing, works. Explain how you're employing it and what you're doing.
Yeah, I think so. It's super cool. Z is really focusing on the issues of EMS at the manufacturing level, really at the shop floor. And we are more looking at the business processes. And I think there's also different forms and business use cases you can look at. We are more looking at these kind of pattern recognition analytical cases. So one big bucket that we have is like, and it's sad that we have this is a big bucket, is data processing. because there's still so much corrupted data. One, like the PCB data, which has been incorrectly labeled from the layer stack all the way to bill of materials, which have come in every form and color and shape you can imagine. And one big part of our engine is really just feeding in that data without you needing to like do prior like Excel magic or prior processing. And we can just turn this into a digital twin. So that's one big part of the application. The other part is then when you go a little bit more into these like suggestions and recommender systems, where you have similarities about which parts have been used like in other projects and that are similar to each other, or the descriptions of a certain part are similar. Can you make recommendations even though they're not, you haven't categorized them perfectly? Because once you've categorized stuff perfectly, then it's an easy lookup task. But if it's something fuzzy, can you find similar part alternatives in times of a part shortage that you can recommend to your users? Then of course you can do like these kind of demand and supply kind of forecastings, but I think forecasting is always something I take with a grain of salt, because you can't really predict the future. You can just only find patterns in the past and hope that they will replay themselves in the future. And then another topic is, of course, similarly to what maybe Z is referring to, if you have, like, which is a similarity search between different projects. If you know this was a project or a specific position on the board where there were issues in a former production case, and this looks very similar to something that you see now, you could mark this position as like a high risk area where a human should put a second view on, which is more of an anomaly detection approach. So you see it's, and I think that's how I think about it when I think about AI these days, is if you use AI to sell your value proposition, you don't have a value proposition. So it's, in theory, it just there's a clear value proposition, and there's probably a classic computer programmed approach to doing it. But then at some point, you're using more sophisticated algorithms to move you one step further. And it's often like a mix of small different models that are just fueling different business cases, and not just this one big machine where you throw everything in and then it spits it out, and that's everything you do.
Everybody thinks that's the future, but it's not. I want to comment on that, and that's the difference where the data comes in. What you see in most AI programs or supportive decision-making tools in the EMS or at the SMT line is that they're using the data that is existing there, which means the machine is providing data all the way about the process, and you take this data and you analyze that, and you get better information on how to utilize the machine. Probably you know the few companies in this area. What we're trying to do is to bring data in, because no one has data on the components, and the component is the most important part of this PCB. Actually, the bare board has nothing with it if there are no components on it. And the concept that we're trying to bring into this AI, and maybe in future stages, the AI companies that try to manage better the process will use it as well, is we are taking all the information about the components and make it available for any AI system that want to use it along the way. So, for example, if we see components with defects or with problems on them that practically cause soldering issues along the way, this information can be used later on by any other AI system when you are actually planning your Gerber. So in the future, we actually will be able to sell this data in a way that you are going to do better designs. Today already, we are providing this data to Siemens with, there's a tool called PCB Flow, where when you are selecting an item for your bill of material, you can go into our database and see what is the quality that so far we have seen on this item, what are the tolerances of the item. So now when you're doing a design, it's not just by spec, but what is the actual life of components that are arriving into the line. And there are there are really big difference in the tolerance. So especially today, where PCBs are getting smaller and smaller and smaller, you need to be much more accurate. And the whole concept is, let's bring data into the process and not just using the data of the process.
Yeah. Yeah. And data's the fuel for the whole system, isn't it? And I guess that's true for you as well, Sebastian.
Yeah.
The more data you produce, the more accurate the learning system becomes. And it's, as Zeev says, the more cats you show it, the more likely it is to recognize a cat from a dog further down through the process.
Yeah, I think there we also have, of course, we are there's constant paradigm shifts happening. And I think this first real wave of AI that has really made it into the applications is from a learning style, is exactly what you described, this kind of supervised learning approach. That means I have a clear data set and I have associated labels to it from a historic set. I want to basically reproduce this on an unseen data set. So what Zeev has been proposing, these are defects and non-defects, and can you label them accurately? But there's of course also more other approaches like unsupervised or self-supervised learning, which are trying to kind of more either find anomalies in a specific system without having you associated this specific label, or where the data itself you've considered coherent, and you're trying to bootstrap some of these labels from it. This is, for example, how these large language models today are trained. Historically, you've been looking through a sentence and have been naming, this is a verb, this is a noun, and then you let the system try to predict that and learn language in that way. And the new systems that are kind of powering already applications today have done a very different approach. They have just been saying, okay, we believe a Wikipedia article itself is consistent, and I'm just gonna hide a few words. I know them, I hide them from the system, and the system has to kind of predict the gaps, similar we learned language in high school or in elementary school.
Yeah.
And this is of course a very different approach to learning that works for some cases, but can really help you bootstrap the whole learning process and allow companies like in OpenAI and DeepMind to build these super large foundation models, which are now more and more used as a backbone for downstream applications. So I think that's also what companies like ours have to really understand, which are horizontal use cases where we shouldn't really start really building something from scratch, but just use something where we can build a next layer on top. And what are other areas where we might have a data edge, where it might still make sense to keep that data flywheel going and improve our models over time. So I think even if no one should be I would say an AI diva that says, okay, I just want to do it for the sake of it, but really make always sound business decisions where you want to spend your R&D resources and where you shouldn't.
Yeah, I like the idea of an AI diva.
Yeah. Hey, I think about this, and I think about the drivers within our industry and what's pushing all this. And I think of, the increased automation that's happening, the pursuit of Industry 4.0, right? And all the hope that pretends. And then I think about the challenges, with all that potential, what impedes that, right? What are those issues, Zeev? What is slowing the adoption of AI in more ways within electronics manufacturing? Is it just people's skill or
is it readiness of the technology
issues, or what are the issues that impede it?
Who takes it, Sebastian or myself?
Go for it, Zeev.
I think it's a matter of education, how to use the results. Because if in the past the results were very clear, there was a person sitting in the end of the line on the AOM station, and he's looking at the results, yes, no, good, bad, etc. Now the results are coming in the line, coming during the process.
Real time.
And the effect of the decision could actually be more than just one board. Could be the whole line, the whole batch, etc. And you expect that the people that are today on the line will make those decisions. And probably they cannot. And I think this is something we're facing today. So we will try to help our customers with people that will actually help them to make the decision online. In some point of time, I think those people today that make the decision will be the ones to make decisions according to the results. And you don't need our support anymore. But it's education phase. Let's say it's the slogan of sorry, too much information. You know what I mean? It's okay, you gave me too much information, I cannot handle it. So I will keep doing what I used to do because so far it works. And this is somehow the way that what we see in the problem in with our results. I think the industry in general is moving through more and more Industry 4.0, but it's a matter of how to really use that. It's not a matter of if it's good or bad. It's obviously good. Everybody wants the information. The data is important. Okay, what do I do with it?
Yeah. How do you get it in front of the right person, and how do you help that person make a good decision? Do you think that's something that slows adoption, Sebastian?
Yeah, I think that's definitely one element. I'm 100% sure that's like how to make people work with the systems, not against the systems. I think it's also, we've seen this, like, funnily, if you basically show the person the same result and says, this is our computer program, and it makes a mistake, then they just like were in the past often more willing to work with the system. But if you say, like, this is generated by an intelligent system, that they say, oh, it's stupid, we don't want to work with it, because it's instantly like humanized, and they are kind of feel it's like kind of their like a decision rival, which it shouldn't be. It shouldn't be a support system, as Zeev said before. I think that's what attitude is definitely one part. And I also agree that I think it's not a topic of technology readiness, because if you look at the frontiers of AI, where they're currently moving, it's more in the generative AI space, for the taking on the creator economy, and a little bit more advanced control, which could have an effect like on how we handle machines, how we calibrate them. But I think most of this analytical AI, like pattern recognition, we see like marginal gains at this point of new models and stuff like that. So if models are not the lever you have, it's all about, one, for the performance, raw performance, the data, as we've said before. And then, of course, the more important part, the infrastructure, making sure that it's actually is usable, it is delivered at the point in time where you really need it. And I think that's where I see the biggest hurdle for adoption, that sometimes you could probably make a model, as Zeev is doing, it could do a task like anomaly detection on a package, or detecting a package extremely well, but you have to have the data for it, you have to integrate it into the right tools. Do you run it on the machine, on the edge? Like, this is a completely different puzzle to solve. I think that's the main challenge at this point.
Yeah, and it's the response to the data, isn't it? As Zeev was saying, how do you respond to the data? Is it a question of operators getting in the way of AI? Are humans a hindrance to the adoption of AI? And when we talked about Industry 4.0, I think in the early stages of the concept, people were talking about self-healing lines. They were talking about fully autonomous lines, where the data that is being generated by Zeev's system should allow the placement machine to make the kind of decisions Zeev's talking about, like discard that component and try the next one. And if the next one's no good, let's have that reel replaced, and to actually make that decision. Is it the case that as soon as we put a human in there, we slow the whole process down? What do you think, Zeev?
I think, today, I'm coming from a kind of a military background. At the end of the game, there is someone that pushes the button. The machine is not making the decision to push the button.
Yeah.
The red button.
Yeah.
And it will take time until the operators of those lines will be able to believe our AI or our software or all the softwares around it to make the decision for the machine and discard parts, replace a reel, stop the machine. It's only done when, it's totally break out the part. I can see so many tombstones where items are twisted in the line and machine is not stopping. Because today there is not yet a confidence of the operators that I can leave the automatic system with itself. It will do everything by its own. Now, I would say there is a robot behind you, so there in the picture. I hope that it would never happen, that we will have full confidence in the machines. So we will stay there alive, still near the machines, but it will progress. So what we need to do is to do two things. We need to educate the market that you can actually believe what we're actually getting out, and the fact that it will be good enough that to make a decision. Sometimes when we make a decision, it relates to things that are not related to the line itself. For example, I have to deliver 10,000 units by end of this night. And if I will let the machine do the work, it will probably deliver 995. So who is right?
Yeah. So you take a lot of other variables into account, which is what humans do, isn't it?
That are not by the machine. So I think it takes time until we will believe the machines to an extent. But it will get there. I mean, it's like everything we did in all the technologies we used to use in the past, and that they were manual, and today we let the computer do it for us, and just a matter of time.
Yeah. If I can spin off that a bit, because Zeev, I think of your application of it, as you've said, it's a yes, no on a component, right? Yes, no, and it's pretty simple. Yeah. But then Sebastian, if I think in terms of like a quoting software that Luminovo does to help with that, that's a tool to repair. And at the end of that, a manager at an EMS company that's employing your software may still make a managerial decision that based on that, in a sense of, do I build it here, do I build it there, right? And there are other components, business considerations that might come into that the system's not aware of, right? So how do you, am I correct in that, in how your software works and how that's employed?
Yeah, I think it's exactly the question of which level of abstraction you're entering, right? For example, is it taking your example, we have a full kind of suite where you can map all your manufacturing costing logic, like basically which resources you have, which human machines, what the hourly rates are, this classic bottom-up calculation that some of these people are doing, and you can map them per site. So our current approach to make it more transparent, because it's also an accounting topic, is like the data is fed in, and then we extract the relevant parameters to feed these systems and to allow you to do a bottom-up calculation. You can basically see, this is what will cost me at site A, this is what it cost me at site B, and then you can say, okay, as you said, it's only a 10% more expensive here, but I know that we need to show more top line in Dallas, because that's because our investors care about that, right? That's a decision you wouldn't want to take away. And that's exactly how we are thinking about it. Similarly, you could also, of course, say you're taking this decision completely away. We're just throwing data at it, and you look at historic analyses of the bill of material and the board, and you say, this board was historically best suited for site A. But I think that's a level of abstraction that's not really needed, because I think that in-between layer is something that helps you for downstream tasks and would also just be way too complex. So I think it's always a question of which small, like, in a sense, input-output problem do you try to approximate with a model, and where and what is one step too many? Similar to an autonomous car, right? There are like systems today that are trying to take vision input and translate it directly into like a steering motion. That's in a sense the ultimate input output that we humans are performing. But it's not, no autonomous driving car is trying to do that, right? They have the vision layer that extracts the boxes, the route drop planning layer. So there's a lot of different intermediate layers that you can also debug more effectively, because otherwise it's a black box end to end. And that I think that it makes this trust issue we talked about before, brushed upon, even more of an issue.
Yeah. I think the trust thing's huge. Also, I think the size and the veracity of the data is a really interesting question. I mean, when we look at the data that you're using, you look at the data that Zeev is using that is taken from either a reel-to-reel or a placement machine or an AOI machine. There's also SPI data on the line. There's data coming out of the ovens. There's a whole lot of data. Is there a sense that if we can get to a position where all that data is available, i.e. we've got a digital twin or a simulation of some kind of every line or of every facility, then it's going to be easier to build AI on top of that because we've got access to all that data. Is that something that should accelerate the use if we start to see factories digitally transformed? Sebastian or Zeev? Go ahead, Sebastian.
Okay. So I think if you could, I think that would definitely make a huge difference if you, in theory, if you have a digital twin that can really like generate realistic results for different scenarios, then of course this allows you to like create infinite data. But then it's also the question, if you have a digital twin that can fully simulate reality, what are you using the model for? So, but what you see often in reality that like, if you have such a complex simulation that works, it just takes too long. So that often you then have this simulation that helps you to bootstrap more ground truth data or create more synthetic examples. But then you're still having a model that helps you predict the outcome, basically bypassing the simulation to have like a quick decision, because you can't wait for like a full simulation to run. And I think that's what you've seen. Also, the advent that we've seen with like the engines that are playing games today, right? They were at exactly the advent that they could work in a simulated environment, could like play game after game, and thereby bootstrap their knowledge and then get to a very quick decision-making engine. And taking that analogy, I think it can definitely help. But it might also just, getting this full digital twin might also just be like take too long and be not something we can ever achieve. And it will rather be like a mosaic, like a piece of multiple small things that are solving one particular issue effectively and fairly well with real world data that's synthetically enhanced, but not this full digital twin that can do everything that people are sometimes dreaming of.
Yeah. Zeev, is that too much information or is that too much utopian?
No, I mean, the digital twin is a different thing. I mean, digital twin can help you with the design, with the training, etc. The data we want to take an effect in the 4.0 is the actual live data that comes from the PCB, the oven, the pick and place machine, etc., which are changing and deteriorating, etc., during the process, and the digital twin will not catch it. So what I believe is that because we are learning day by day how to better use this information, yes, it will be used, but we need to build, let's say, knowledge how to use the tools. It's not build another tools, it's just build internally knowledge of the operators, of the decision makers, how to use the tools, because now we provide them more information that will help them to make better decisions. But still, we have the man in the loop. So the man in the loop now what we need to try to do is build the data in a certain way that the man in the loop will be able to make a decision. Not to give him 25 options and now we need to choose one, because he's not able to choose out of 25. We need to give you one or two, then he is able to choose. And we need to make it clear why he can choose between one or two or three. But if you need to choose out of 25, there's no way you're going to choose the right. There's no selection here. So
Yeah.
I think the problem is not in the technology, is actually more in the decision-making processes. And I think what if Sebastian type of services to help people understand how they need to do the process is actually something that's very needed, because now they understand how to position the people in the process that will make the right decision at the time. So it's not just the data; it's just it's a process.
Yeah. Hey, I'm just kind of curious. You know, the EMS industry, as we're talking about, is clearly global. It's in most of the main geographic regions of the world. Is the adoption of AI and machine learning what we're seeing clearly is present there? But I was reading something about the adoption of it in kind of from regional comparison, and that stated that kind of APAC, Asia Pacific, seems to be more in the lead of it, maybe that followed by Europe and then maybe North America. How do you view that? Is there something, Zeev, I see you shaking your head in disgust there. So
I don't see any differentiator between the APAC and the European one.
Really?
It's I think it's more personal.
So it's company by company, regardless of their geography. What about you, Sebastian?
Well, I can just talk from some personal experiences. So definitely, if you look at the education level, when I was like at Stanford 2015, 16, and late 17, that was where the courses and what was taught there at school and like the understanding of the field was, I would say, 2 years ahead of Munich, Germany. And I think that was exactly the kind of like opportunity we seized at the time to make use of that knowledge gap or that gradient. And I think it's also a great book by Kai-Fu Lee, who's one of the well-known figures in the AI space, that talks about AI superpowers, China, Silicon Valley, and the New World Order, which is basically makes it very visual why he basically says China will be the dominant superpower in AI, because it's about how they educate their people, that we are currently not in an AI research age anymore, so in an AI implementation age, where there's just so much mathematical knowledge and eagerness to implement based on the like historics and the history of the country, that they basically see this like a willingness to adopt technology like that, and it's anyway powering also negatively their everyday lives, right? With like the social scores and stuff like that. That I would definitely say that the adoption there is a lot higher compared to like Germany specifically, or Europe, with the whole GDPR topic was basically a huge, like I would say also excuse for managers for not getting into that topic, because it was always super easy to say, oh, we can't do it because of GDPR.
You can't use that data. Yeah,
exactly. And we can't use that data. I think for us, it's less of a problem, right? Because there's no personal data in a Tombstone resistor. But like we've also worked at business process level, and there, of course, personal data is a topic. And I think it's still like basically a deaccelerator for the whole field. Yeah. And specifically in Germany, it starts even earlier. It's about the cloud adoption, where it's still where people still think it's more secure to have your buddy Hans managing your own servers compared to like Microsoft Azure or AWS or Google or something. So I think that there's definitely something in the mentality that also would see what you brushed upon, not just on a company level, but also maybe on a mentality level where there's like maybe a little bit of a different approach to it. Tel Aviv, I would say, people are like on a very different front.
Yeah, it's interesting, isn't it? It's like its own little Silicon Valley, and there are different locations where it's being driven harder. I want to just return to the question at the very beginning: can AI make EMS smarter? And I'm kind of curious about where you see perhaps the soft targets, the low-hanging fruit for AI. You've obviously got applications that you've both chosen to work on, but you've both got a strong knowledge of what an EMS factory looks like. Are there areas that you see appropriate to apply AI, and are there areas that you see that we should just steer clear of and not dabble in. Zeev, any thoughts? Any other processes without giving away any big secrets?
No, but I think AI in general is part of this coming century. I mean, we now know how to deal with vast amounts of data. Because if 10 years ago, if I needed to store and manage 2.5 billion images, probably I could not afford the amount of computers, or I mean, it would probably something that I cannot do, especially not as a startup. So we know how today to manage vast amounts of data, and we have the mathematical tools to understand it, to build out of it, etc. So it will grow all the time, because the data, nobody deletes anything practically today. What's the last time you cleaned your computer?
That's why it's so slow.
Yeah, that's right. No one is cleaning his computer. It's not happening. So so I do see it's flourishing, because the data is there. If the data is there, we have more applications. If the data is there and we find things. Now, for example, what we are going to do is give our data to universities.
Okay.
And actually use the brain power. Actually, we're doing it with the University of Maryland, and give them the ability to go into those amounts of data and do whatever research they want to do. And this gives options which are unlimited. I don't know now what are those guys that are working in doctorants are going to imagine in 5 years. But I know I'm going to give them the data that if they will find out what to research, they will find a result which might be beneficial to everyone in the EMS market. We are in the EMS market, so that's the thing. It's the same thing as I look at it, same as we look at the medical data. In the past, you didn't have enough data to make research. Today, in Israel, it's very obvious. Today, you can buy actually access to 2.5 million people blood tests for all their life. You can start working tomorrow. But I mean, not one blood test for one person, from the age when he was born to the day he died.
Yeah.
And you can use that data for your research.
It's phenomenal.
So it's endless.
That wouldn't happen with GDPR, would it?
Yeah.
With all that data protection in Germany. So is it a question of, the larger the data, the larger the problem, the more attractive it is for AI? I look at things like manufacturing planning, for example, production planning, complex tasks like that. Are they areas that you look at, Sebastian, see those as opportunities for AI to actually provide incremental value, or at least provide advice and support to those that are making the decisions to derive better outcomes?
So I think generally one thing that, like Zeev also mentioned, is I think very, very interesting, that I think this combination, how can we get the data from basically the actual manufacturing lines back also up into business processes where the decisions are actually made, right? Like similar to what you described, like if there's models that find anomalies in the actual production, like funnel this back and say, hey, how can we already detect this early on? And ideally, I think that's the main interesting application. Funnel it all the way back to the developer, right? To the OEM that is actually designing that board. And I think for me, it's about like closing that feedback loop. And I think that's generally a huge opportunity that we're only getting incremental value from. But besides that, I mean, you mentioned like manufacturing planning. I think there's always this: can you use an AI system for it? And also, but then on the other hand, what's the added value that we see? And I think if I look at it, it's really about like, is research delivering fundamentally new models, new paradigms in that space? Or is it like, do we have like a new novel data access that we can tap into? And I think, as I said, the frontier of the models is more in the like generative and reinforcement learning planning space. And I think really you have the robot behind you. I mean, Tesla demonstrated their Tesla bot, which is of course still like very far from like reality. But I think this last piece of closing that manufacturing loop, like to go to Industry 4.0, probably will come into a humanoid form if you don't want to build a new factory from scratch. We'll see how far that goes. But I think that's, if we look for the next huge leap, I think that's going to be it. And the rest is going to be like incremental applications that are really detecting defects better, or recommending parts better, or predicting, forecasting your demand better. Like these kind of areas where it's just we've touched upon all of them, I think, or most of them, but we just need like a next layer of innovation to move them a little bit further.
Yeah.
Very good. Listen, gentlemen, I got to be respectful of the time here, and we're coming to an end. So as we wrap, though, let me just ask you each for regarding your own companies and what you're seeing. It's clear from this discussion that AI is kind of ever evolving. There are more opportunities out there. What do we have to look forward to from your companies in the next year, or as you move forward here? Zeev, how do you view that?
I mean, we are, let's say, we built, the AI is our enabler. Without AI methods, we could not do what we're doing practically.
Mm-hmm.
I mean, that's the way. There is no way to do what we are doing today with normal programming that was in the past. So that's for sure. And what we see up front is to be able to actually help the machines to actually drop the items that are not good, and as well bring the traceability of products to the level that I would say there will not be any more major electronic recalls. So we are able today, with the technology we have and with the kind of information we have on the boards that we are working on them today, to help our customers that if there is a fault, and always there is a fault, we are all engineers, so there's no 100%, then their recalls will be actually very small and very accurate. And that's a lot of hidden money in the industry. Most of those recalls, nobody knows about them, nobody speaks about them because nobody is really proud about them, but they're happening. And we are able, and that's our goal, is to help the industry to make it much cheaper to that on day life, and to do it fast. Yeah. So if you have a problem, takes you an hour, you know the 100 boards you need to bring back. That's it.
Yeah.
You don't need now 5 weeks investigation, database cleansing, etc. Few clicks on the button, those are the boards I want back, they're coming back, and I can replace it, and I have a happy customer. Remember, today, the automotive industry, just we have a guy here, which is a volunteering policeman. And yesterday, he said he had an issue of BMW 750, something like that. It's an electric car, which is the top BMW, on the highway, stopped. And if there is even no way to move the gear shift from parking to neutral, to put it on the loading front.
Because it's made the decision. Yeah.
It made the decision to stop. And this is our life going to be much more and more, because our life today is electronics, and we need to act fast.
Yeah. Yeah.
Interesting. Sebastian, what do we have to look forward from you?
So I think when it specifically comes to this like intelligent applications, I think what we are like looking forward to contributing is the industry-wide like utopia of shifting information left that has been around for 10 years. And I think we are like finally in a position where we can really make that happen, because all our software is basically cloud native. So you talked about the data. We basically have data available to give access and draw knowledge from it, and then really like the information, the knowledge that was before only available for a PCB manufacturer, how can this impact the life of the EMS? And the knowledge that was before only available for the EMS, how can this influence the decision of the OEM? So I think that's for us this idea of gathering the knowledge and data and making in a sense predictable engines from this that can are completely in a sense non-leaky of in identifying information. So it's clearly just like a decision-making engine that is not leaking any private or proprietary value or information, but can still help one step further in the chain or before in the chain to make better decisions. And I think that's something we all been striving for, to ultimately really bring the idea to market readiness, this development cycle of electronics down, because the electrification of our world will only continue. And I think there are vital innovations fighting climate change and whatever, and future of healthcare and so on, that are dependent on our industry. And if we can only, coming back to where we started, saving money is cool, but cutting time to market by 50%, that's where the music starts to play. And if we can play a vital role to this, then I know why I'm getting up every morning.
Yeah, and as Zeev says, actually reducing recalls and reducing waste, and they all have a very positive impact on the environment and on the whole industry. What I think is really interesting is, two minds are better than one, as we say on the Eric Miscoll show. Two hosts are better than one. Maybe two AIs are better than one. And when the AIs start to be able to teach and talk to each other, then there's all kinds of magic that could potentially happen on the factory floor and in the supply chain. So I think it's hugely important technology for the EMS industry. There's just so much data coming out of the line that it's the only way to manage it and deal with it and use it to make better decisions.
Yeah, no, amen to that. Gentlemen, this has been fantastic. Thank you very much for taking time out of your days to kind of share with us and with our audience. I think everybody is a little smarter at the end of this than we were. I know I am than I was at the beginning of this, and that means it was an hour well spent. So hopefully we can catch up with you in the future and get some updates on this, because clearly the application of both of what you're doing continues at a good speed. So thank you. Enjoy your days, and look forward to catching up again.
See you all in Munich.
See you in Munich.
See you in Munich.
See you in Munich. You too, Sebastian.